Assalamualaikum warahmatullahi wabarakatuh and hi semua. Welcome back and this is video part 8. Okay, in this video, I will explain the determination of solid surface area using BET and Langmuir methods. Okay, let's begin. In the previous video, I have shown on how the isotherm is obtained. Okay, from the shape of the isotherm itself, you may predict some characteristic of your solid sample. Besides that, there are other information we can obtain from the isotherm, which are the surface area and porosity. The surface area can be determined using two methods, which are Langmuir and BET methods. In general, Langmuir determines the surface area at monolayer adsorption when theta equals to 1, while BET predicts the surface area based on the multi-layer adsorption, typically at P over P naught range between 0.05 to 0.3. First, let's consider the determination of surface area by BET method. Okay, from the BET equation, where P over V times P naught minus P equals to 1 over Vm times C plus C minus 1 over Vmc times P over P naught. We plot a graph of P over V times P naught minus P against P over P naught. So this is the y-axis and this is the x-axis. Okay, again, only consider P over P naught in the range of 0.05 to 0.3. Otherwise, your data will not accurate. A straight line graph we produce where the slope S equals to C minus 1 over Vmc and the intercept I equals to 1 over Vmc. Okay, rearrange this equation, then we can determine the Vm equals to 1 over S plus I and the C equals to S over I plus 1. Where Vm is the volume of adsorbate gas at monolayer adsorption and C is the BET constant. The surface area of the solid sample can be determined by measuring the amount of a particular adsorbed gas with non-molecular cross-section area. Maksudnya kalau kita tahu cross-section area of the gas, which is AM, then darabkan dengan bilangan gas yang adsorb, then we can calculate the solid surface area. So the solid surface area is equals to S equals to Nm times Am times N naught, where S is the specific surface area, where the unit is surface area per 1 gram of solid, Nm is the number of moles per gram of adsorbent in monolayer, Am is average area occupied by 1 molecule adsorbate, and N naught is the Avogadro number. If the monolayer gas capacity is stated in gram xm, so for the number of moles here equals to xm over m, where m is the molecular weight of the absorbent. Okay, here the unit is Armstrong squared per gram. Convert the unit in meter squared, then S equals to xm over m times am times n naught times 10 to power of minus 20. Now the unit is meter squared per gram. Okay, if the monolayer capacity is stated in terms of gas volume at STP Vm, therefore S equals to Vm over 22414 times Am times n naught times 10 to power of minus 20. As mentioned in the previous video, usually we use nitrogen gas as the absorbate. So, for the nitrogen gas, the cross-section area AM can be calculated as AM equals to F times M over rho N naught power of 2 over 3, where F is a packing factor, which is equals to 1.091. M is the molecular weight of nitrogen and rho is the density of the nitrogen gas. So that for nitrogen gas, where the density equals to 0.81 gram per centimeter cube, and molecular weight of nitrogen is 28.0134 gram per mole. So, masukkan semua value ni dalam equation AM. Then finally, we get AM equals to 16.2 Armstrong squared. Then convert to meter squared. The AM equals to 16.2 times 10 to power of minus 20 meter squared. Okay, so the surface area of a solid S equals to VM over 22414 times 16.2 Armstrong squared times the Avogadro number times 10 to power of minus 20. Then finally we get S equals to 4.35 times the VM. And the unit is meter squared per gram. Okay, these are example of data that we can get from the nitrogen adsorption instrument. So from that we can get the isotherm plot and a summary of data. Okay, contoh isotherm macam ni, ada relative pressure P over P naught and volume of gas absorbed. Okay, let's say from this data, we want to determine the BET surface area. So we have to recalculate the data in terms of P over V times P naught minus P versus the P over P naught. Plot the graph, then we get a straight line graph like this. Then determine the intercept and the slope of the graph. And then calculate the VM, which is equals to 1 over S slope plus the intercept. And finally, the surface area S equals to 4.35 times the VM. Okay, in this example, the surface area is 21.6226 meters squared per gram. Now, let's consider the determination of surface area using Langmuir method. Actually, we have discussed this topic in video part 3. So, here kita ulang semula for revision. Okay, as we know, the Langmuir equation, theta equals to Kp over 1 plus Kp, where theta can be expressed in terms of the volume of gas absorbed, V over Vm. Okay, then rearrange the equation. We get P over V equals to P over Vm plus 1 over KVM. And there are other alternative form, which is P over P naught over V equals to P over P naught over Vm plus 1 over KVM. And then rearrange, we get 1 over V times P naught over P equals to P over P naught over Vm plus 1 over KVM. Then, sama macam BET, this is a linear equation. So, plot 1 over V times P naught over P versus P over P naught. We get a straight line graph, which the slope S equals to 1 over Vm and the intercept I equals to 1 over KVM. Okay, thus Vm equals to 1 over the slope and K equals to slope over the intercept, where K is the equilibrium constant. Okay, so the surface area equals to 4.35 times the Vm and the unit is meter squared per gram. So 4.35 here again if we use the nitrogen gas as the absorbate. As for example, let's say you are given some isotherm data like this. Okay, then from the data, calculate the surface area, Langmuir surface area. So what you should do is first recalculate the data in terms of 1 over V times P naught over P versus the P over P naught. Then from the data, plot the graph. So a straight line graph we produce. From the graph, determine its slope and intercept. And then calculate the VM. Then from the VM, calculate the Langmuir surface area. So sama macam BET. Okay, that's all. And this is exercise for this topic. So you can try to answer the question first. Okay, with that, that's all. See you in the next video and bye-bye.